Good afternoon to all. So we completed your fourth module in the last class. Now we are going to start with your module 5. So the module 5 of your syllabus of your microcontroller and embedded system consists of RTOS and IDE for embedded system design. So where RTOS stands for real-time operating system and IDE is integrated development environment. So now what will be the course objective for this particular module? So it is going to basically explains the real-time operating system which will be used for the embedded system. Okay, so it is comprehend the real-time operating system used for the embedded system. So after this particular module is completed, you are going to be able to know what are the real-time operating systems which are available to build the embedded system. Okay, and what are the different IDEs, that is integrated development environments, which you can use to develop the applications to run the embedded systems or embedded applications. Okay, so let us move to the chapter. So this particular module is basically describes you about the basics of your operating system, which have already been learnt in your operating system subject, which will be taught as a separate entity only. Okay, so first thing, start with the operating system. Okay, so next, when you begin with the operating system, what do you mean by operating system? So if you take the layman's definition of the operating system, so our operating system acts as a interface between the user and the hardware. So that is what the basic definition of your operating system is. So according to the textbook, the basic definition of your operating system, it acts as a bridge. Okay, between what? So between the user application. So here it is your operating system is acting as a bridge between the user application, and first one is user application, second is your system resources, underlying system resources, through what you are going to use through what you are going to access those system resources through the set of system functionalities and services. So your system is going to provide some system functionalities and services. With the help of those system functionalities and services, you are going to access the different resources of the hardware. Okay, so your underlying system resources is nothing but the hardware. So if you talk about the general definition of your operating system, it will be acting as an interface between the user and the hardware. So now next comes the question, what your OS operating system is going to manage, what it is going to manage. So basically it is going to manage the resources which you are going to have in your hardware. So either it may be a CPU, or it may be a memory, or it may be a process. So it is going to manage the resources, or we can tell that it is going to manage what are the components which you are going to connect to the system, and then what are those resources which you are going to manage it. So it also make it available to the user application. So it is going to be made available to the user application as and when it is required by the user. So depending upon the user, so depending upon the requirement of user, so that particular resources will be given. Okay, depending upon the user access to the resources. Okay, user access to the resources. Okay, so after seeing all those things, after seeing the functionality of OS and what is the operating system behaving as, so let's come to what is the primary function of your operating system is. So if you take the operating system, what will be the primary function of the operating system? So now the primary function of an operating system is what? So it has to make the system convenient to use. So I have to use the system. So it should be user friendly, right? So that particular system should be user friendly. So it should be user friendly. So that's why it is called as system convenient. So that means whatever the resource I have to access and whatever the application I have to access, it should be accessed freely. Okay, so with handy I have to use that one. And then apart from those things, when you are using those resources with easy access, so after that one, it has to organize and manage the system resources efficiently and correctly. So after using the applications according to the need of the user, so even that other functionality which your operating system has to provide is it has to organize and manage. So it has to organize and manage the system resources. Okay, so how it has to organize and manage efficiently and correctly. So it has to organize and manage the system resources efficiently and correctly. So that will be the primary function of your operating system. So now if you take the architecture of your operating system, how the operating system look like. So as we have seen that, so your operating system is acting as what? So your operating system is acting as a so if you take the operating system, so your operating system, what it is going to tell? So the operating system is acting as a interface. Okay, so it is acting as an interface between what and what? Between the user and the hardware. So this is nothing but user and hardware. So this is nothing but your operating system which you are going to have. Okay, so this will be acting as what? This will be acting as an interface. Now, on top of your OS, so if you want to access the user applications, what you require? You require the APIs. So you require the API, where the API stands for Application Programming Interface. Now, when you want to access the hardware, underlying hardware, if you want to access, some set of device driver should be there. Okay, so if I have some set of device driver, with the help of the device driver, you are going to access the different components of the hardware. So if any hardware has to work efficiently, means what? You should have some device driver. Okay, you should have the device driver. So then only it can work efficiently. Okay, so now when it comes to the OS, so what it basically provides? So if we talk about the OS, so OS is nothing but it is running the kernel. So kernel is nothing but the heart of the operating system, as of all of you know that one. So it will be heart of the operating system. So what are the different services provided by your kernel? So when you are going to have the kernel, so some set of services or some functionalities your kernel has to provide, right? So what are the different services your kernel has to provide? The services which the kernel has to provide is, one is memory management. Okay, so it has to provide the memory management. Second is it has to provide the process management. Okay, so third, it has to provide the time management. Fourth, it has to provide the file system management. Fifth, it has to provide the IO system management. So these are the different services. Okay, so these are the different kernel services which your operating system has to provide. So your kernel is nothing but what? Heart of the operating system. So all of you know that one. So this is what the typical architecture of your operating system. So we will see one by one. Okay, so how this will be organized. So before going for one by one, so let us discuss what are the different types of operating system you are going to have. So if you take the OS architecture, okay, so the previous we have seen that. So OS is nothing but what? It's a core of the operating system. Okay, so core, or in some books it is going to refer as the heart. Is it right? So your kernel is referred as a heart of the operating system, or it is going to call as a core of the operating system. So what is the functionality of the kernel is the next question. Okay, so when you talk about the OS is mainly used to manage the resources. Since kernel is also a part of the OS and it is a heart of the operating system, so even the kernel is responsible for managing the system resources. Okay, so it is responsible for managing the system resources and the communication between the hardware and other services. Okay, so that also it has to provide, because if when you are going to have the systems, okay, system resources are there, right? So like your hard disk will be there, like some RAM is there, and we are going to connect the printers, which is external hardware. Some scanner, I'm going to connect it. So now if I want to make my printer to work, I should have the communication, right? So I have to manage the hardware with the connect your system resources or the process with the hardware, and you are going to connect your system with the scanner that I have to work. So and the communication has to be made between your system and the either with the connected hardware. Okay, so what it is going to provide? So your kernel is basically responsible for managing the system resources, and the second operation what it is going to perform is basically it is also provide you the communication. Okay, so it's also provide you the communication among the hardware and the other system services. Okay, so that's going to have. So that's why your kernel is called as what? Your kernel is called as the abstraction layer. Okay, so it is going to have to call it by the abstraction layer between the what and what, between your system resources and user application. Okay, so that is what you are going to have when your operating system functionality when it comes to functionality. So here you are going to have, as the name indicates, so it is going to have the it is going to have the abstraction between the system resources and user application, right? So now how it is going to obtain that one? So how it is going to provide you an idea? So how it is going to access the resources? So if I want to access the resources, I should have written some functionality, right? So what are the different functionalities I should have? The kernel should provide. So kernel contains the system libraries and services. So whatever the kernel you are going to have, so it will be having some system libraries and services. Okay. So with the help of those system libraries and services, your resources will be managed with the help of these system libraries only. So the resources are managed. Okay. So now when you take the general purpose OS, okay, so if you take a general purpose OS, so the kernel contains different services. What are the different services your kernel is going to provide? So your kernel provides what are the different services? It is going to provide basically a process management. So next, it is going to provide you the primary memory management. Third, it is going to provide you the file system management. Fourth, it is device management, or any device if you are using. So you are going to do what operation? You are going to do the input and output operation with respect to that particular device. So you should have the managing your device also. That is, you should have the IO system for that one. So that will be a fourth. So next you are connecting your hard disk. So if even the hard disk has to be managed, so your hard disk will come in your secondary storage management. So all those things if you have, so the data has to be protected. Whatever the data you are going to have in your system, that has to be protected in time to time manner. So when you are protecting it in time to time manner, you should provide the what protection to your system. So that is one of the services which your operating system is going to provide. So next is time management. So next you are going to have the time management where you are going to manage the time and whatever the task here. So a task has to run how? So within the specified amount, within a certain duration of time. So time has to be managed. So I should, when I'm giving some task to work for the OS, it should not wait for 1 day. So within some known amount of time, that particular task has to be completed. Certain duration of time. Okay. So that has to be done. That care has to be taken care by your kernel. So next, whenever the external interrupt comes, okay, it has to serve. Because if your request is coming from the scanner, assume that. So it has to store the picture which is scanned in your scanner. So then it is the request is coming from where? So the interrupt is coming from your scanner. So then it has to be served, right? So you are going to have the interrupt handling for that one. Okay. So these are some of the services which your OS is going to provide. So that is your general purpose OS. Okay. So when it comes to the OS architecture, so as you know that it is having the two space. That is, what are the two space? One is your kernel space, other is your user space. So you are going to have two space. One is your kernel space, other is your user space. So now, what are the program code which are there? So the program code which are corresponding to the kernel application services, where it will be kept. So that is primarily kept in the contiguous area. So that is called as OS dependent. So where whatever the program code you are going to have when it is running in the kernel mode, so whenever the task is running, it is going to run in two mode. That is, one is your kernel mode, other is your user mode, right? That you know already from the basic concept of your operating system. So now when it is running in the kernel mode, corresponding to the kernel mode, where this particular program count will be kept. So if you take the kernel, so you're going to run the program. So where this particular program code is kept. So where this particular program count is kept. Okay, so basically your program count, what is going to be kept, it will be in contiguous area. So you're going to have the area, so where you are going to keep that particular program code. So that particular Contiguous means what? Continuous. Okay, so it will be kept in the continuous area. So then that is OS dependent. That particular area is OS dependent. So it is nothing but the primary memory. So that is nothing but your RAM. Okay, so whatever the program code you are going to keep, so that particular code is kept in the RAM. So in the RAM, how it will be kept? That will be in contiguous memory location. So even the RAM will be having some memory location. So in that program code will be kept in RAM in contiguous memory location. That is in the continuous memory location it is going to be kept. So then whatever the data you are going to run through the primary memory, so it should be protected, right? So whatever the data you are going to keep in RAM, so no one should be permitted to access that particular part of the code. Okay. So now when you want to have the access restriction for that particular part of the code, a protection has to be given from an unauthorized user. So a protection protect it that particular part of the code, which is when it is running in kernel space, that will be protected from the unauthorized access. So that will be protected by the unauthorized access by the user or program application when your program is running in kernel mode. So now whenever you are going to have the memory, okay, so if you take any program, means what? It is going to be stored in some memory, right? So finally it is going to be stored in some memory. So some here when the kernel is there, even the kernel will has to be stored in some memory. So the memory space at which the kernel is located, okay, so that part of the space is called as kernel space. The code space in which the kernel code is located, okay, so that is called as kernel space. Now another applications which you are going to have is user applications. So now where your user applications will be loaded is the next question. Okay. So if we talk about the user applications, so basically the user applications are loaded to a specific area of memory. Okay, that will be loaded to a specific area of primary memory. Now, and this particular part of the memory is referred as user space. So in the user space, what is going to run? User application. So in your user space, it is going to run the user applications. So now even this particular user space has to be loaded to where? Even this particular user space has to be loaded to a specific area of primary memory. So as you have seen already, all of you know gone with the memory hierarchy, right? So all of you know how the memory hierarchy is going. So first it is going from tape disk or primary memory. Next is going to with the primary memory. Next it is going to have the cache. Next is the register. How the data will be flowed. Okay. So now when it comes to the primary memory, so even the application which you need to run, so has to be learned into the primary memory, has to be loaded into a specific area of the primary memory. So now that particular part of the code, that area is referred as what? User space. So that particular part of the code is referred as the user space. So for that one, what is happening? Partition is going to happen there. For that particular thing, a partitioning of memory has to be done, which will be differentiating your kernel space as well as the user space. So now the partition of memory, which will be done depending upon your kernel space and the user space. Okay, who has to do that one is the next question. So if you take the partitioning, so partition has to be done with respect to the user space and kernel space. Okay, so if you take the kernel space and user space. So when you talk about the kernel space and user space, these two things which are there, so that will be what dependent? Operating system dependent. Okay, operating system has to take care that which part of the code has to go to the kernel space and which part of the code has to go to the user space. Okay, so operating system should know. So what type of resources you are accessing. So if you are accessing the resource from the system, so then it has to be loaded into the kernel space. So if it is from the application, that has to be loaded into the user space. Okay, so that mainly depends upon whom? That mainly depends upon the operating system. So that mainly depends upon the operating system which you are going to have. Okay, so now when you are going to have the OS architecture. So when it is running with respect to the your kernel space and user space, here if we take, so operating system which were a operating system, a kernel space is nothing but what? So it is an operating system with virtual memory support. Okay. So if we talk about the kernel space, so operating system with virtual memory support should be there. So it is going to have the memory. So that particular memory is nothing but virtually. So virtual means what? Physically it is not there, but logically it will be available. So virtual physically not available, logically available. Okay, physically not available, logically it will be available. So that is how your virtual memory support is going to take place. So next, when you are going to have this particular kernel space, so basically what it is going to do, so first it is going to load the user applications. So you are going to have the user applications. So that particular user applications, it will load the user applications into its corresponding virtual memory. Okay, so space with demand paging technique. So first what it is going to have, so it's going to have the virtual memory. So it is going to have the virtual memory space. So in that particular virtual memory space, it is going to load your user application. So now when you are going to have the virtual memory space, it has to be done. So I have to make use of the demand paging technique. So it is nothing but what? It is nothing but like your book. You have the book, you have the file, or you are a book you are there. So if you are going to have the book, so your book contains what? Pages. Okay, if a book contains pages in your book. So now, as and when the pages got over, so assume that my pages which are there in the book is empty pages I'm going to have. If I'm going to have the empty pages, what I need to do? I have to demand book. Okay, so demand book is there, but what the book contains? Your book contains pages. Your book contains pages which you are going to have. So that is the same thing what will happen in your operating system also. So whatever the data you are going to keep or whatever the data you are to execute, that has to be stored in some memory. So here the memory is nothing but your file. Okay, it's treated as your file, normal file, that's it. You map it to that one. And whenever that particular memory is not available, okay, so what I need to do, I have to ask that particular memory from whom? From the operating system. So that particular task is called as demand paging. So when you are going to ask space or pages from whom? From OS. It will ask the OS pages from OS. Now, what will happen? What the most of the operating system will keep at that time? So what is the what where your operating system is going to keep? So now here, so you can see it here. So when most of the application, most of the operating system, what it is going to keep is, so it is going to keep the kernel application code in the main memory. Okay. So what your most of the operating system keep? So your operating system kernel application code, it will keep the kernel application code in main memory, and that is not swapped out into the second memory. So what it means? So that is not swapped out means what? Whatever the memory you are going to execute in the primary memory. So when that particular space is not available, okay, it won't move to the second memory. So how it will be done? So if you recall your concept of the operating system or memory hierarchy with respect to the computer organization. So basically where the data will be stored initially it will be stored in the secondary memory, right? So when initially it will be stored in secondary memory or tape disk or compact disk. So we're going to have tape disk here. So after that one, it will be having secondary memory. Next, it will be having the primary memory. So next, it is going to have the cache. So in the cache, it may be L1 or L2. That depends upon the type. So always the L1 cache resides inside the processor itself. Next, it will be the register. Now, whatever the recent executed instructions are there, okay, so that will be stored where? In the cache. So your cache holds recently executed instruction. So recently executed instructions will be stored in the cache. So now when you are going to have this particular recently executed instructions which are there in the cache, so what will happen there? So next, So if space is not available, assume that I have 1 MB of my application to run. Okay, so now some of the applications has to run in primary memory. Assume that, so your device driver. So that means it has to control all your hardware which is connected to your operating, which is connected to your system, right? So even those device driver are nothing but your system call. So this is nothing but system. That is, it has to run in the kernel space. Okay, so now this part of the code, it will be running in the kernel space, that is in the primary memory. Okay, so next, some of the application will be there. So the some of the applications will be there. So those applications, it will be running in your primary memory. Okay, so when you are going to have that one, so now once after certain limit, okay, so I have the limitation of my primary memory. For example, now you have 4 GB of RAM or 8 GB of RAM. So now once that particular application is filled, or some of that particular size is filled now. If that particular size is filled, what I need to do? I need to, if the application size is 5 GB, for example, I am telling. So now I cannot fit whole your application here now. So part of the application has to be shifted out. So at that time, your virtual memory is going to come into the picture. So at that particular time, your virtual memory is coming into picture. So what is going to do at the time? So virtual memory, which is going to have here, okay. So here, so it is going to take, so the virtual memory, so the memory is going to have your primary memory, for example, I am telling. So in the primary memory, it is going to have the system. Okay, so the program code will be there, as well as your user application is there. That is kernel code as well as user code. Now I cannot shift the kernel code out to the secondary memory. So that's how the execution is going to go, right? So how, if this particular space is not available, something it is going to execute in your secondary memory, but I cannot move the kernel code into the secondary memory. So that is why it is telling that. So the kernel application code in memory, and it is not swapped out. So whatever the code which is running in your kernel, whatever the part of the kernel, it is running in the primary memory, that won't be swapped out from the primary memory to the second memory. So only part of the application code. So if some applications will be running, right? So the application code will be moved to the your secondary memory. So that is user applications will be moved to the secondary memory. So that's how your operating system will be managing the resources. So that is what it is not swapped out into the secondary memory. So that's what it is going to tell. So it is similar to the analogy. If I tell, I have the book, which is a confidential book. So so what will happen? So I have some account data. So important will be there. Some more pages I'm going to write it in some other applications, right? So now, if that particular file, for example, is filling data, so what I need to do, whatever the important data is there, I will keep in this particular file, and whatever the applications which are not important, so that I am going to move it to the next file. So the same thing it is going to happen in your operating system also. The important file, it will be keeping in your primary memory. The files or the application which is not important, that will be moved to the secondary memory. Okay, so that's how your virtual memory concept is going to work in your operating system. Okay, so now when it comes to the operating system, so there are different approaches for building an operating system kernel. So what are the two different approaches you are going to have for building an operating system kernel? So one is your monolithic kernel, other is your microkernel. So this already you have read. So what do you mean by monolithic kernel and what do you mean by microkernel? So next, when it comes to monolithic kernel, so in the monolithic kernel, what will happen? Most of the kernel services which you are going to have, it will run in the kernel space only. So in monolithic kernel, what will happen? So all your OS services running. So all your OS services which are running, so that will be running all in the kernel space only. So OS services will be running in the kernel space. It will be running in the kernel space. Okay. So that's what it is going to happen. Now here, when you talk about the all kernel modules, so if you take the all kernel modules which are there, so that will be running within the same memory space under a single thread. So it's going to have the main process, okay, main process which is in the kernel. So within the main kernel, it's going to create only one thread. Only one thread will be created. Inside this particular kernel thread, only that particular module is going to run. So that module runs inside this particular thread only. Okay. So all your kernel modules, whichever the kernel modules is nothing but what? Which are the modules which are having the direct access to the resources. Okay. So those are called as kernel modules. So that is going to have the high privilege. That particular module will be having the high privilege. So now when the kernel modules runs within the same memory space under a single kernel thread. So now how the internal integration is going to be done. So here the internal integration of kernel modules in monolithic architecture is shown below. So you can see it here. So how the internal integration of kernel modules are going to be done. So now when you are going to have the internal integration of your kernel modules, what it is going to provide, it is going to allow you the effective utilization. It is going to allows the internal integration, what it is going to done. So the internal integration, it is going to provide the effective utilization. Okay, so it is going to provide you the effective utilization. So effective utilization of the low level features of the underlying systems will be there. Like your hardware may be there, like primary memory or secondary memory, and storage like LAN card may be there. So even that one requires the drivers which will be having running in the kernel space. Okay, so when you are going to access the low level features of the underlying system, so your kernel is going to provide you the effective utilization. So it is going to provide, the kernel provides effective utilization. That's what it is going to tell. So the kernel provides the effective utilization. So it provides effective utilization which you are going to have under the monolithic kernel. So when we talk about the monolithic kernel, so all your kernel services will be running in a single kernel space. So all your OS services. So what we have discussed, like file management may be there, for process management may be there, file management, process management, memory management, IO management, interrupt handling, all these managements will be running in a single kernel space only. So when you are going to have the, when you are using your monolithic kernel. So in the microkernel, it is going to have the limited features. That's it. So whatever the features it is required, only those features it is going to take. So apart from that one, it is going to remove all other features which is not required. Okay. So that is what. So basically, it is allows the effective utilization of the low level features. Okay, of the underlying system. So next, when it comes to the monolithic kernel, what is the main drawback? So even if you have the monolithic kernel, when you are running your all your OS services in a single address space, you are going to have some drawback of the monolithic kernel. So now, what is the drawback? If any one of the process fails, so that means I am going to have the process, it is running in a single thread, I am told, right? So in a single thread means what? I'm going to have one process management is there, memory management is there, I am going to have the file management is there, I'm going to have the IO management is there, interrupt handling is there, right? So these are running in a single thread only when you are going to have the monolithic kernel. The problem is if any one of the kernel module fails, so even if you take one process management fails, if process management fails, then what will happen? The entire process will be terminated. So the entire thread will be killed, what we can tell. So the thread is spoiled. So when you are going to have the spoil, what is going to have? You are going to have the crash of the system. So crash of the entire kernel application is going to happen. So when you are going to have the crash of the entire kernel application is going to happen, what is going to have? Your system goes down. Your system goes down. So that's why some of the times you are telling that my system got hanged. What do you mean by that one? So when one of your OS services fails, it will normally happen when your system is infected by virus, because normally virus will affect your .exe file only. Okay, so when you are affected with some of the OS services file, so your entire system will be hanged or your entire system will get crashed. So that is the main problem which you are going to have in your monolithic kernel. Okay. So when you talk about the monolithic kernel, what are the different examples? What are the different operating system which you are going to have in your monolithic kernel? So the first one is Linux. So the first one is Linux. You are going to have Solaris. You are going to have MS-DOS. You are going to have. So these are some of the monolithic kernel examples, operating system. So monolithic kernel is nothing but the operating system. So these are the example of monolithic kernel OS. So that is Linux is one example. Solaris is another example. MS-DOS is also another example. So this is this particular operating system. Even if we take some of the other versions will be there. So, but at the time of the writing of the book, so these are the examples which are there. So that is Linux, Solaris, and MS-DOS. So this is about your monolithic kernel. So when it comes to the microkernel, so next when it comes to the microkernel, so here what do you mean by micro? As the name indicates, micro. So it is going to have the limited services. Okay. So micro means what? Small. So what services it is going to have? A OS services. So it is going to have the small OS services. So our small in the sense is like what? Which is having the essential services. So essential set of OS services will be loaded into the kernel in your microkernel. So inside your microkernel, what will be loaded? So what are the essential set of operating system services? It will be loaded into the kernel. Because when we discuss with respect to some applications like memory management or my file management, process management, or interrupt handling, or IO management. So when you take about the monolithic kernel, more amount of hardware will be involved there. So the more amount of IO operations has to be performed. So there I have to give more services. So when you're going to have the micro, small, limited services. Okay. So only the essential set of system services, operating system services will be provided in system services will be reside inside the kernel. So now, whenever you are going to have the rest of the services, if you want to make use of the rest of the services, the rest of the operating system services are implemented in programs. So those programs are referred as servers. Okay, so those programs will be referred as servers, which will be running in the user space. Okay, so other operating services which are there, so that will be implemented as part of the programs, and that particular programs will be running in servers, and which in turn will be running in the user space. Okay, so here when you are going to have the server, so the servers will be running what? Kernel services running in user space. So that whatever I cannot fit in this particular kernel, I'm going to shift to the user space. So either application will be having microkernel with essential service like memory management, process management, and time management. So servers, what it contains? Servers contains the kernel services which will be running in the user space. Okay. So this is a typical figure of your microkernel, whatever we are going to be represented. So it is not going to have the single processor, single thread. So we are going to have monolithic kernel. It is going to have the single process, single thread. So it is not having the single process and single thread. So where whatever the process you cannot fit into the kernel, so those processes will be running as an application in the user space. Okay. So which will be acting as a part of the kernel here, and which forms the part of the kernel. Okay. So if we take the kernel example of that one, so you're going to have the QNX, Minix is there. So even if we take VxWorks is there, another. So most of the RTOS, that is most of your real-time operating system will come under microkernel only. So most of the real-time operating system. So most of the real-time operating system will come in microkernel. So next comes the question, what are the benefits of microkernel? So similarly, with respect to the monolithic kernel, here also you are going to have the benefits of microkernel. So now if any problem is encountered in any service and server, so it can be reconfigured and restarted without the need of the restarting the entire OS. So that means what? I'm going to have some services which will be running. So, but some of the services will be running in user space. So when your service is running in user space, what will happen? So it's typical example what you can do. So I can use Control-Alt-Del and I will go to the task manager. I will end that particular application that you will be doing frequently in your home. So that is what. So what you are going to delete in the task manager, that will be running in the user space, which you can be viewed. Okay, so that will be running in the user space. So even if any problem is encountered in any of the services which is running in kernel space, or server. Server is outside your kernel space. So that particular part of the services can be reconfigured and it can be restarted without the need of the restarting the OS. Okay. So another is configurability. Start the OS system. So any server application which is running, so those server applications which will be running as part of your process. So the restarting the whole system. Okay, so that's how it will be done. And what are the different types of operating system? That is monolithic and kernels.